Okay, hi. Okay, welcome back everybody. Today we are still doing energy, okay, but we are doing a new set of energy over here. We are done with potential, we are done with kinetic. Okay, today we'll be looking at electrical energy and sound energy. Okay, so I hope you have tried your questions. Okay, let's go through the questions now. Okay, first question, we have a diagram where you have a dynamo that converts kinetic energy to electrical energy. Okay, the word dynamo, for those of you who have not come across this word yet, a dynamo, most often scenario they will put in is a bicycle. Okay, so if you have come across this before, a bicycle containing a dynamo, what does a dynamo do? What is the energy conversion inside a dynamo? Okay, this is it. They convert kinetic energy to electrical energy. Okay, but in this case, the dynamo is placed in just a circuit, and the kinetic energy over here is from the running water that goes through the water wheel over here. Okay, so let's look at the question first, what they want. They ask you for what can be done to make the bulb glow brighter. Okay, bulb glowing brighter, first you have to understand that to do this, you need more electrical energy. Okay, and energy cannot be created, right? They can only be transferred and converted. So this more electrical energy must have come from somewhere. Okay, let's look at options A, B, C, D. A says raise the tap higher. Okay, raising the tap higher, will it cause any increase in any types of energy? Answer is yes, because by doing this, you are increasing the gravitational potential energy of water. Okay, so you have more energy at the start, that will give you more electrical energy at the end there in the light bulb. Okay, lower the tap. No, lowering the tap means less GP, is the opposite of A. Okay, A is correct, so B is wrong. Okay, C, raise the wheel higher. Raising the wheel higher means that the water, okay, when it falls, it will hit the water wheel earlier. That will not lead to more energy because the distance between the water wheel and the tap is smaller. Okay, this will lead to a decrease in the amount of kinetic energy. So lowering the water wheel, okay, what's this? Lowering the water wheel, making the water wheel further away from the tap will result in more kinetic energy of the water. So more kinetic energy means that you're going to end up with more electrical energy in the bulb later on. Okay, so A and D is correct. Answer for question 1 is C. Okay, let's move on to question number 2. Okay, use the information below to answer questions 2 and 3. Keith placed a solar panel at a location in the field to produce electricity using light energy. Okay, he noted the amount of sunshine daily and recorded it in a table. He wanted to find the average amount of sunshine daily for each month. Which of the following formula should he use? Okay, average amount. So each month, you must have a certain number of days. To find the average, you must divide by the total number of days in the month. Okay, so what must he collect per day information? You must collect the total number of hours of light per day, right? And divide that by the when you collect the total amount of light per day, you're gonna collect it for the whole duration of the month. So let's say 30 days. So each day you collect light amount, and then you tally up each and every one of that data. Correct or not? You add day 1 how much, add to day 2, add to day 3, and so on. And then you take the average, means the total amount of light you collected for the month, you divide it by the number, let's say 30 days. Okay, so the correct answer here, okay, number of hours per day, total number of hours of sunshine for the month divided by the total number of days in a month. Okay, this one I think is just testing on whether you understand how to make use of all the variables inside the question. Okay, Let's take a look at the next one. Question 3. Keith placed a solar panel at a location in the field to produce electricity. Okay, so it's the still the same context. Okay, but now he has a graph done up. Okay, so now he has the average amount of sunshine daily for January, February, March, and April. So in which month did the solar panel generate the greatest amount of electricity? The more the amount of sunshine, the more the light energy, the greater the amount of electricity can be converted from it, right? So of course we're going to pick March. It has the highest amount there. Okay, no issue with this one. Everyone should be getting this correct. Okay, let's move on to question number 4. Eugene prepared 4 setups. The dynamo, again, there's the word dynamo here, converted kinetic energy to electrical energy. He put the setups at 4 locations. Okay, but this kinetic energy, right, from where did it come from? Previously, it was from running water. Running water got movement, right? So got kinetic energy. Okay, over here, it's not about running water anymore. They have a windmill. So the source of kinetic energy here must be the wind that is giving you that kinetic energy you need at the start. Okay, so then he recorded the brightness of each bulb in the table below. At which location was the wind the strongest? Wind the strongest means that you're going to have the highest amount of KE. So highest amount of KE later will lead to more, or the highest. Let's not put more, let's keep it consistent. Okay, let's put highest electrical energy. So the bulb will be very, very bright. Okay, so we have bright and very bright. So of course, answer for number 4, A. Okay, we have to pick the best answer, ma. Okay, let's move to question number 5. Which of the following are the advantages of using hydropower to generate electricity? Hydropower, the word hydro means water. So in this method of generating electricity, you're going to get your energy from running water first. So this is your, wait, I'm going to put it here. This is your running water. Running water has kinetic energy. Okay, so they want advantages, right? So let's take a look at A. Its supply is unlimited. Yes, as long as you have water and you can move the water from a higher place to a lower place, it's going to rush downwards very fast. You're going to have unlimited supply of kinetic energy. It does not cause pollution. Yes, because what you need is just water. You're not burning fuels, releasing smoke, releasing carbon dioxide, releasing greenhouse gases. So it's just running water through a water wheel or a turbine. So B does not cause air pollution. C, the construction of large dams destroy wildlife and their habitat. This is true. Okay, this is true. When you make dams are not small, okay, they are huge. That's why in Singapore you don't have an actual full-size dam. You maybe have a small one over at Marina Barrage area there, but definitely not the big ones like you can see in other countries. Okay, so to make large dams, okay, you actually have to clear out spaces. Wildlife will be affected, their habitats will be affected. Sometimes even villages can be affected as well. Okay, so there are cases in India where the small villages around certain areas where they want to make the dams, they are forced to be displaced or they are actually paid to move out because they want to create the dams there. Okay, so does this sound like an advantage? No, it sounds like a disadvantage. Okay, so C out. Okay, D, the electricity produced by using a hydropower station is cheaper than produced by burning fuel. True. Okay, because why? You have unlimited supply, so it's easier to obtain running water rather than easier to obtain fuel. And then also you have to build large factories for fuels and put in all the safety measures and everything, manpower, okay, to monitor and manage the factories and all. So overall, dams are cheaper to produce. Okay, so answer here A, B, and D. C is the answer for question number 5. Okay, let's move on to question number 6. Okay, Susie. Susie grouped several objects according to the main forms of energy that they produce. Which of the following shows the correct headings for P, Q, R, and S? Okay, P, you have coal and wood. Coal and wood, you obtain the energy inside them via burning. So therefore, they must contain some chemical potential energy somewhere. Okay, so P, I will tick potential, potential, potential. Hit wrong already. Wait a minute. Hang on. Am I reading the question wrong? I think I read the question wrong. They ask you according to the main form of energy that they produce, that they release, that they generate. Okay, so when I say that the coal and the wood contains potential energy, we get the potential energy trapped inside your coal and the wood by burning them. Correct or not? And when we burn fuel, not fuel, sorry, when we burn coal, we burn wood, what energy is actually produced? Heat energy. Correct or not? So heat is the one that I should take because that's what the question wants. Okay? Potential is wrong, 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 because potential is what they have, not what they will produce when we try to obtain and release the energy inside them. Okay, so let's take a look at Q. Loudspeaker, alarm clock. These objects, loudspeaker, alarm clock, what kind of energy will they produce? They are very noisy kind of devices, right? So they will produce sound energy, moving train, flowing water. These are moving things over here. You got the word moving there some more. Okay, so definitely the energy that they will produce is kinetic. Okay, lastly, television, fluorescent lamp. These two give off light energy. Okay, so answer here D. This question I think need to read carefully, right? Because cannot be tricked by what they want. Okay? Okay, let's look at question number 7. Which of the following possesses energy that is different from the rest? Waterfall is running water. Running water possesses kinetic energy. Bowling ball rolling down the lane. Rolling here is movement. Movement is kinetic energy. Okay, glass falling from the table. Falling here is a type of movement. Movement have kinetic energy. Fully charged batteries. Batteries is an example of CPE, chemical potential energy. So the different one here, answer B. Okay, all right, we are done with our MCQ. Let's move on to our open-ended. Okay, open-ended number 1, question 8. Wen Jie had 2 similar drums. He placed a few grains of sand on drum A, and then he go and hit drum B with a drumstick. And then he observed that the grains on drum A vibrate each time he hit drum B. But again, drum A and drum B are a distance apart. The grains of sand are on the other drum. Okay, so when he beat drum B, he realized the grains of sand also got some tiny movement, vibrations. Okay, so first thing first, they ask you what is the energy change that took place from the point when Jie hit drum B to the point when the grains of sand started to vibrate. Why I circle those two? Because that is my start point and that is my end point. Okay, so first you need to consider what energy is inside Wen Jie that makes him able to move the drumstick. And then when the drumstick is moving, what energy was converted, was transferred, and then finally move it over to the grains of sand on the other drum. Okay, so how you're going to write it is like this. It's going to be a bit long. Okay, the chemical potential CPE, the CPE in Wen Jie, okay, is converted. Must you write about food and everything? No need. You don't have to explain until that. Okay, so this one is unnecessary, but it's not wrong. It's okay to give it. But if you want to avoid any confusion, long answers, unnecessary long answers, then you don't have to put it in. Okay, it's just for your understanding. How come Wen Jie got chemical potential energy? Because he ate food, and food contains chemical potential energy. The energy now is transferred and stored over in Wen Jie's body. Okay, so CPE in Wen Jie converted to, so let me box up first, converted to kinetic energy of the drumstick Okay, because the drumstick's moving, he's moving them to beat the drum. And then also